Good morning, class, and welcome to lesson 6.1.1, Can I Solve a Triangle? Today's lesson, and going into tomorrow's lesson, actually all week, you're going to be finding angles and sides to non-right triangles. So we're going to be using the law of sines today, and then we're going to study an area formula for a triangle. Tomorrow we'll be doing law of cosines. The triangle is a very important shape. Triangles are used in engineering construction and are the basis for navigation, surveying, and GPS. Solving triangles is also an important skill. In this lesson, you will derive general formulas for the law of sines and an area formula for triangles. Law of sines proof. In the figure at the right, A, B, C denote the sides opposite angles A, B, and C respectively. Use the diagram to complete the following problems. Given that triangle ABC is an acute triangle. Acute means that there are no angles that are 90 degrees or more. Write an equation to express H in terms of angle A and side length B. So we're talking about angle A, side length B, and H. Well, that is the sine function. So if we think back, the sine of angle A equals opposite H over B. Or another way to do that, if I multiply both sides by B, I now have B times the sine of angle A equaling H. Part B, write an equation to express H in terms of B, angle B, and side A. So now I'm going to take H in terms of angle B, side A. Well, again, that's the sine function. So the sine of angle B has to equal opposite, which is H over A. Another way to write this, if I multiply both sides of the equation by A, is A times the sine of angle B equals H. Hey, here's what we have from the previous page. Use your results from parts A and B to show that the sine of angle A over A equals the sine of angle B over B in this particular triangle right here. Well, since this B times the sine of A is equal to H, and A times the sine of angle B is equal to H, I can set those equal to each other. So I have B times the sine of angle A equaling A times the sine of angle B. Now what I'm going to do is I'm going to divide this side by B and this side by B. At the same time, divide this side by A and this side by A. So I'm basically dividing both sides by A times B. What that leaves me is these B's cancel, those A's cancel, and I now have the sine of angle A over A equaling equaling the sine of angle B over B. So we just proved that statement to be true. So what if we drew an altitude to side AC instead and followed the same method? Now notice I had to change this. Originally said BC, but we're going to change it to AC. So I have this altitude going from vertex B down to AC, it's the dotted line. It forms a 90-degree triangle. And so now if I take a look at angles C, H, and A, I have the sine of angle C equals opposite over hypotenuse, or another way to write it, multiply both sides by A times the sine of angle C equals H. I also have on the other side this piece right here. I have angle A, H, and C, and the sine of angle A equals opposite, which is side H, over C. Multiply both sides by C, and H equals C times the sine of A. And just like what we did up here in part C, I'm going to set these equal to each other. So I have A times the sine of angle C equaling C times the sine of angle A. I'm going to divide both sides by A and C. These cancel, and we are left with the sine of angle C over C equaling the sine of angle A over side A. Now let's put all of this together. The sine from up here, right there, from the statement, the sine of angle A over side A equals the sine of angle B over side B. But the sine of A, angle A over A, also equals the sine of C over C, equals the sine of C over C. And this is what we call the law of cosines. Excuse me, that's tomorrow's lesson. The law of sines. And so, into our next slide. An example using the law of sines. Nathan lives 200 feet downriver from Tong. Both live across the river from Stacy. Nathan views the other two houses at a 100-degree angle, while Tong sees them at a 38-degree angle. So what we're really saying is, I think Nathan is in this house, Stacy's in this house, and Tong is in this house. So we want to be able to calculate the distance between Nathan and Stacy's house. So using our law of sines, I'm going to call this A. And the angle opposite A is 38. So the sine of 38 degrees over side A has to equal some other ratio that we know. This is 200 feet, and the angle opposite it happens to be 42 degrees, because of 180 minus 100 minus 38 gives us 42 degrees. So then the sine of 42 over its opposite side, which is 200. Let's cross multiply. A times the sine of 42 equals 200 times the sine of 38. Divide both sides by the sine of 42. And A equals 200 times the sine of 38 over the sine of 42. So then A equals 184 feet, or 184.018 feet. Now, they also want to find between Tong and Stacy's house. Well, Tong's side, let's call that side O. O is a bad letter to use. Let's just call it X. 100 is the angle opposite that. So I'm going to set up one ratio as the sine of 100 over X has to equal another ratio, which is any given side and given angle. Well, let's again use that 200 feet and the 42 degrees. So the sine of 42 over 200. Now, taking just a little bit different approach than what I did up above, let's get rid of fractions by multiplying by our denominators. So I want to multiply by x times 200. I'm going to multiply the right side of the equation by x times 200. And if I do that, then my 200s cancel. And I'm left with x times the sine of 42. And if I do that to the right side, and I erased a few things, so now if I take and multiply x times 200 to the left side, here my x's will cancel, and I'm left with 200 times the sine of 100. And now I want to solve for x, so I'm going to divide both sides by the sine of 42. So I get 200 times the sine of 100 divided by the sine of 42. And x then comes out to be 294.354 feet. So that's using your law of sines to find missing sides of triangles. Let's take a look at a formula for the area of a triangle. Since side angle side determines a unique triangle, it should be possible to calculate its area given the two sides and angle between those sides. A similar method to the method you use to prove the law of sines can be used to generate a formula for the area of a triangle in this situation. Note that we have to assume angle C is going to be less than 90 degrees. Write an equation for the area of triangle ABC. Well, my general formula for area of a triangle, area equals 1/2 times the base, which is B, times the height, which is H. But then we also know that if I use angle C over here, H is opposite, A is the hypotenuse, that the sine of angle C equals H over A, and if I multiply both sides by A, H equals A times the sine of C. Now we're going to combine these two statements because h equals the sine, or a times the sine of c, and in this formula I have an h. I'm going to plug this in for h. And my formula, then a equals 1/2 times b times a times the sine of c. Or another way to write it is 1/2 a times b times the sine of c. This means if I have an angle C that is between two sides, A and B. In other words, we have side, angle, side. I can use those two sides and the angle between them to find the area. So let's go on to the next slide and use our law of sines and our area formula for a triangle to find missing sides and angles in the area. So we want to find missing sides and angles in the area for the triangle below. What I'd like you to do is pause this, find those things on your own, and then come back and check your work. All right, welcome back. And here in the black, we have us finding the measure of side A, or the length of side A. And to do that, I took the sine of 78 degrees over the opposite side, and that's the key piece. These are opposite of each other. Sine of 78 over 8 equals then the sine of 80, because angle A has to be 80 degrees. Here's the reason why. So then the sine of 80 over its opposite side, A. I got rid of my fractions, ended up with A sine of 78 equaling 8 times the sine of 80. Divide both sides by the sine of 78, and you get a value for A of 8.054. Over here, you can look through this. I found side C to be 3.064 units. And then finally now for the area. Remember, you can use any two sides as long as there's an angle between them. And so I'm going to use A and B from up above. A happens to be 8.054, B happens to be 8, and the angle between them is 22 degrees, so I have the sine of 22. Type that into your calculator, and the area of this triangle is 12.069 units squared. So, in summary, your law of sines talks about an angle and the side opposite. You're always setting up this ratio of my angle A over the side opposite. That has to equal any other angle and its over its side opposite. So you're setting up this ratio equal to a ratio. And this only occurs when you have an side angle side or an angle angle side. Area of a triangle. Remember, A and B have to have an angle between them. So I can use A and B right here as long as I've got that angle C between those two sides to find area. And so you can use any two sides. Take A and C. If you were given side A and side C, you can use that provided you have angle B between them. Hopefully you enjoyed this lesson. Tune in tomorrow for lesson 6.1.2. Have yourself a great day.